Hi guys, welcome back to the channel. My name is Jag, and in today's class we're going to continue with our Chemistry 11 content, and we're going to move on to the next gas law. Okay, so the next gas law is Gay-Lussac's law, and so with that, let's get started. Okay, so here we are. I wrote down the equation for Gay-Lussac's law, and this is P1 over T1 equals P2 over T2. Okay, so let's just define what the variables are here. I'm going to put P1 and T1. Okay, so these are basically the initial, pressure and the temperature output of the gas, okay? Whereas when you're looking at P2 and T2, these are going to be the final pressure and temperature, okay, of the gas. Everyone see that? Okay. So if you look at the formula, I can see that the pressure of the gas is directly proportional to the temperature. Okay, so what this means is as you're increasing the pressure of the gas, the temperature also has to increase. Okay. So I'll just put like an increase arrow sign like that. Okay, and the same thing for the final, okay, pressure increasing. The final temperature has to increase as well. So remember, there are different values, okay, in terms of the pressure and the units. However, the temperature should be in Kelvin. Okay, so with that, let's try an example here. Okay, so again, I'm going to read the question out loud. Okay, so determine the pressure change when a constant volume of gas at 1 atm. So I have my P1 value is 1 atm, and it is heated from 20 degrees Celsius. Okay, so we have T1 is 20. Okay, and one more time, you have to make sure you're adding 273 in order to change this into Kelvin. So I'm putting 293 Kelvin, okay? And it is heated from 20 degrees Celsius to 30 degrees Celsius, okay? So T2, so 30 degrees, and we'll just put plus 273. Okay, so again, I always make sure I write down what is given, and I do all the calculations right here, okay? So maybe let's write given at the top. Okay, and it does determine the pressure change. Okay, so what I do is I write down what is required, and what we're looking for here is going to be the value of P2. Okay, so just like this. So what you're going to do is just rewrite the equation and make sure you're always writing the equation, okay, before you plug it back in. Okay, so just like this. I'm going to plug in my values now, okay? So P1 is 1. Again, no need to actually put the units here, okay? And the T1 is 293. We are looking for P2. And T2 is 303. Does everyone see that? Okay, and now we're going to cross multiply this. So I'm going to make an arrow so everyone can see. So the P2 value is going to be 1 times 303 divided by this third term, which is 293. Okay, so just like this, we're going to put it in our calculator. And I'm going to round it here, okay? So 1.03 atm, okay? And you can see that the pressure difference here at 1.03 atm is really small, okay? Because I'm only starting with 1 atmosphere here. And the change in temperature as well is not very great. That's why the change in pressure is not going to be that great as well. Okay, does everyone see how to do that? Okay, and are there any questions? Okay, so that looks good. Okay, let's try another example here. Okay, and with this example, I want to just use a different unit, okay, in terms of the pressure. Okay, so again, I'm going to just read the question out loud. So a gas container is initially at 47 millimeters of mercury. Okay, so for those of you who are not sure, this is millimeters of mercury. It's mmHg. Okay, And this is actually the pressure that's used in like thermometers. Okay, so there is an actual application, like a real world application to this. So the gas container is initially at 47 millimeters of mercury and at 77 K. So this is liquid nitrogen temperature. So I'm going to put T1 is 77 K. Okay. What is the pressure in the container when it warms up to a temperature of 25 or a temperature of 25 degrees Celsius? Okay. And we're going to change that again into Kelvin, so 298 K. And you'll notice that the temperature of 25 degrees Celsius is used quite often, okay, as room temperature. Okay, so let's write given here. So this is what's given. And again, what is required, okay, is going to be the pressure change, okay? So P2. So let's write the equation here. P1 over T1 equals P2 over T2. And then we're going to just plug in our values that we have. So 47 is P1 over 77, which is T1. Okay, and I'm going to make it equal to P2, because I'm looking for that, over T2, which is 298. Okay, does everyone see that? Okay, so one more time, we're going to just cross multiply this over here. Okay, and I'm going to make an arrow so we can see that. So P2 equals, okay, 47 times 298. And you're going to divide it by the third value, which is 77. Okay, and that's going to be the value of P2, okay? And again, if you're actually looking for the temperature, okay, and the pressures are given to you, make sure that the pressures are in the same units. Okay, so we are getting 181.9, okay? And this is millimeters of mercury. So one more time, make sure you are watching, okay, in terms of like the units here. This is not in atmosphere. And when you have the pressure in atmosphere, okay, the value is going to be really small. All right? Okay, are there any questions here? So with that, let's try one last example here, okay? And this time, the question we try is going to include us looking for the temperature, okay? So I'm going to read out loud. A gas thermometer measures the temperature by measuring the pressure of a gas inside the fixed volume container. A thermometer reads a pressure of 248 kilopascals kPa, okay? And this is at 0 degrees Celsius, okay? So we're going to do 0 plus 273. Okay, so this becomes 273 Kelvin, okay? What is the temperature when the thermometer reads a pressure of 345 kPa, okay? Okay, so again, this is what's given to me in the question, okay? So you can see there's a pressure change, and what I'm looking for, okay, is basically how does the temperature change here? This is the final temperature we're looking for, okay? So again, don't get confused. We're just going to use the same formula here. So P1 over T1 equals P2 over T2. And then plug it in here. So P1 is 248 over the temperature. The T1 is 273. This equals to P2, which is 345. And I'm looking for the final temperature, okay? So you can see you're just using the exact same formula here, okay? This time when you cross multiply it, make the arrow like this. So you can see it. 345 times 273. So we cross multiply that. And then you're always dividing it by the third term here, which is 248. Okay, so this is going to be our value, okay, for T2. So 345 times 273. Over 248, okay, and we are getting 300, and let's just round that, okay, so we're going to round it to 380, okay, Kelvin. And this is our final answer, okay? So in terms of the temperature, okay, I would make sure that I just round it to the nearest whole number, okay? And again, what if the question said, what is the final temperature in degrees Celsius, okay? So what you would do here is I would take the 380, okay? And again, I have to make sure I am memorizing the constant value. I'm going to subtract 273, and this would be 107 degrees Celsius, okay? So just like that. Okay, so again, this question doesn't ask you, okay, to change it into degrees Celsius. However, if it does, I have to make sure I'm just subtracting 273, okay, from the actual answer. And that's your temperature in degrees Celsius. You can always check your answer, all right, in terms of whatever value you're getting. I can see a pressure change here of 248, and it's increasing to 345. That's why the pressure or the temperature of 273K is increasing to 380. And you can see as the pressure changes, the temperature is also changing, and it's almost proportional, okay, in terms of the temperature change here, just as the pressure is changing, all right? And that's a good way to actually check your answer. Just do a mental check, okay? And make sure your answer always makes sense. All right. So that looks good. And that brings this video to an end. Thank you so much for watching. I hope everyone did learn about how to apply Gay-Lussac's law and how to calculate the pressure and the temperature changes as long as the volume is kept constant. So thank you for watching, and please make sure you do like, share, and subscribe to the channel, and I'll see everyone next time. Thanks. Bye.